Alright, so that's all well and sweet, but now I guess it's time to have a look at some worked examples on how to sketch the graphs of some cubic functions. So let's check it out.
Alright, so this question says sketch the graph of y equals x multiplied by x plus 3 multiplied by x minus 4, showing all points of interest. Now, whenever doing this, what we need to do is first of all go through and find the y-intercept. So to do that, what we need to do is we need to make x equal to 0. So let's go through and write the equation of the line. That is y is equal to x bracket x plus 3 x minus 4. Going through now, making x equal to 0, so I get y is equal to 0 multiplied by 0 plus 3 multiplied by 0 minus 4. Therefore y is equal to 0 multiplied by 0 plus 3, well it's going to be 0 multiplied by 3 multiplied by 0 minus 4 is negative 4. And of course 0 times anything is going to be 0, so therefore y is equal to 0, giving me a coordinate of 0, 0, because my x coordinate was 0 and my y coordinate was 0. Now what we need to do is find my x-intercepts. So for x-ints, I make y equal to 0. So go through and write out the equation of the line again. So there's y is equal to x bracket x plus 3 x minus 4. Make y equal to 0 now, so you get 0 is equal to x plus 3 x minus 4. And therefore what we need to do now is make every linear factor, or every factor that you can see an x in, equal to 0. So therefore you get x is equal to 0, x plus 3 is equal to 0, and x minus 4 is equal to 0. Therefore x is equal to 0, x is equal to negative 3, and x is equal to 4. This will give us the coordinates, or the x-intercept coordinates of 0, 0, negative 3, 0, and 4, 0. Now what we need to do is go through and plot these points. So we're going to plot the point at 0, 0 to start off with. And I write 0, 0, negative 3, 0, so come over to negative 3, 0, and write negative 3, 0, and 4, 0. Come over to 4, 0, and write 4, 0, like so. Right, so now that's all well and good, but what we need to do is actually think about the shape that the graph's going to take. Now, I know that it's a positive cubic because there's no negatives out the front of the x's, so because of that, I know that the graph's going to go up to finish off with. That means I come to the last x-intercept, and I know if the graph's going to continue going up as it goes from left to right, the graph's going to look like that. Now, if you have a think about each one of the x-intercepts as well, what we know is that they are all linear. So that means that they're not going to be turning points at any of the x-intercepts, it's just going to go straight through the line. So that means if this one's going up here, this one's going to be going down, and this one's going to be going up. Now hopefully you can already start to see the shape of the graph that's taking place in your head. But let's just double check some things. So what we're going to do now is we're going to actually have a look at our CAS calculator in order to be able to help us out with sketching this graph, because we need to know roughly whereabouts the turning points are. So let's go do that. Alright, so on your CAS calculator, what you're going to do is open up a graphs page, like so, and you're going to enter in the equation of the line, that is x multiplied by x plus 3 multiplied by x minus 4. Press enter, and as you can see now, the graph looks like it does there. But, of course, that doesn't actually show the full graph, does it? Because it's been cropped out because of the screen size. So what we're going to do is we're actually going to zoom out so that we can see the full graph. So you're going to go Menu, we're going to go Window Zoom, and we're going to go Window Settings. Now I recommend having the same window settings on your calculator as the axis that you've got on your page. So to do that, we're going to go, our x minimum is negative 5, our x maximum is 5, our x scale we'll leave as auto, our y minimum, well that's going to be negative 30, our y maximum is going to be 20, and we'll leave our y scale as auto as well. Press enter. And now what we can see is the graph, and the full graph that is. So now what we need to do is have a look at how to find the turning points. So in order to do that, you're actually going to go Menu, you're going to go to Analyze Graph, and we're going to find the maximum turning point first on the left hand side. So to find the maximum turning point, you're going to go to the left hand side of it, just tap on the screen, you're going to go to the right hand side of it, tap on the screen, and up comes the coordinates negative 1.69 and 12.6. If you see here, I'll just move it around. There we go, so now that I've moved it over, you can actually see that it's negative 1.69, 12.6. So what we're going to do is we're going to plot that point over on the graph. So negative 1.69, which is roughly here, and 12.6, which is going to be roughly here. and we write out negative 1.69, 12.6. So now we're going to find the minimum turning point, so that is we go menu, we go analyze graph once again, we go minimum, we go lower bound, which is to the left of the turning point, upper bound, which is to the right of the turning point, and up comes the coordinates 2.36 and negative 20.7. So we go over to our graph once again, we go 2.36, so that's going to be roughly around about here, and negative 20.7, which is going to be roughly down here. We write out the coordinates of the turning point, 2.36, negative 20.7, and now what we're going to do is we're just going to go through and join the dots. So we know that the graph is going to go from here all the way up through the X-intercept, touch the turning point, come down through the turning point, and go up like so. Remember to draw arrows on either end of the graph and write out the equation of the line, that is y is equal to x bracket x plus 3 x minus 4. And there you go, that's how you sketch the graph of that function. Alright, so now it's time to press pause and attempt the following question, that is sketch the graph of y equals negative bracket 2x plus 3 multiplied by x minus 3 squared, showing all points of interest. Remember when you're done to press play so you can check your solutions against mine. Alright, so welcome back. Now the very first thing I've gone through and done is I've looked for the y-intercept. Now I've done that by making x equal to 0, so I've written out the equation of the line here and swapped 0 in for x, as you can see. So that gets me y is equal to negative bracket 2 times 0 plus 3 multiplied by 0 minus 3 squared. Now 2 times 0 is 0, and I've left the rest as it is. What I've done here now is I've gone 0 plus 3 is 3, and 0 minus 3 is negative 3, and left with the squared there. Negative 3 squared is 9, and that gets me y is equal to negative 3 multiplied by 9, which is negative 27. So therefore the coordinate of my y-intercept is 0, negative 27, because my x-coordinate was 0 and my y-coordinate was negative 27. Going through now and finding my x-intercept, I make y equal to 0, so I've gone and I've written out the equation of the line, as you can see here. Then what I've gone through and done is I've substituted in y equals 0. So that gets me 0 is equal to negative bracket 2x plus 3 multiplied by x minus 3 squared. Now I need to go through and solve for each factor here, so I've got 2x plus 3 is equal to 0 and x minus 3 is equal to 0. Therefore what I need to do here is I subtract 3 from both sides, getting me 2x is equal to negative 3, and then I divide both sides by 2, getting me x is equal to negative 3 on 2. This gives me the coordinate negative 3 on 2, comma 0. Over this side I've got x minus 3 is equal to 0, and when I solve for x it gets me x is equal to 3, so that gets me the coordinate 3, 0. Now what I need to do is go through and plot these points. So I go to 0, negative 27 to start off with. So 0, negative 22, 4, 6, 7, just here. And I write out the coordinate of the point 0, negative 27, like so. I then go over to negative 3 on 2, that's negative 1 and 1/2, so that's negative 1 here, so negative 1 and 1/2 will be here. And I write the coordinate of the point negative 3 on 2, comma 0. And then finally I go to the coordinates 3, 0, so I go over to 3, 0 like so, and I write the coordinate of the point 3, 0. Now what I need to do is consider the shape of the graph once again. Now I know it's going to be a negative graph, so I know that at the final x-intercept the graph needs to be going down like so. What I also know is when I look at this equation, what I've got is I've got a linear factor and a quadratic factor, because this here, x minus 3 squared, means that it's actually a quadratic factor because of this square part here. So what it means by this quadratic factor is that it's actually going to be a turning point at the x minus 3. So it's not actually going to go through, it's just going to go up, touch on the line, and then come down like so. At the 2x plus 3 one, or the negative 3 on 2, 0, what it's going to be is it's just going to be a straight linear line because it's a linear factor. And it's going to be going down like so. So what we know is it's going to go down, come down to here somewhere, go up through, touch on 3, 0, and then come back down and continue down. What we now need to know though is whereabouts the turning points are in order to be able to sketch the graph accurately. So let's use the CAS calculator to find that out. Alright, so now that I'm in the CAS calculator, I'm going to go graphs, and I'm going to enter in the equation of the line. That is negative 2x plus 3 multiplied by x minus 3 squared. Press enter, and up comes the graph. Now once again we can't actually see the full graph here, so what we need to do is change the window settings. So to do that I go menu, window zoom, window settings, and I want to make them the same as the axis that I've got on my page. So I go x minimum is going to be negative 3, My x maximum is going to be 5. I'll leave my x scale as auto. My y minimum is going to be negative 30. My y maximum is going to be 20. And I'll leave my y scale as it is as well. Now, as you can see from this graph here, it actually fits in the picture really nicely. So now what we're going to do is we're going to go through and we're just going to find out the coordinates of the turning points. So to do that, I go menu, I go down to analyze graph. I'm going to go to minimum first of all to find the minimum one. I go lower bound to the left, over to the right, and it says my turning point is at 2.29 times 10 to the power of negative 8, comma, negative 27. So what that basically means is 0, negative 27, because 2.29 times 10 to the power of negative 8 is really, really small. Now, if you have a look over on this graph here, we've already got the dot at 0, negative 27, so that's fantastic. Now we know that the other turning point is actually going to be up here at 3, 0 because it's a quadratic factor, so we don't need to look for that. But we'll go through and do it on the CAS calculator just to prove it anyway. So we're going to go menu, going to go analyze graph, find the maximum, go to the left or the lower bound, go to the upper bound, and of course 3, 0 pops up, which is what we expected anyway. Alright, so now if I go back to my graph, what I can do is just join all the dots and sketch the graph. So I know it's going to come from up here, go down through the dot here, have a turning point at 0, negative 27, continue it on, come up here like so, turning point at 3, 0, and go like that. And we'll just have the arrows at either end, and we'll write out the equation of the line, that is y is equal to negative bracket 2x plus 3, x minus 3 squared.